Hello and welcome today to our webinar for the AutoScan Inspec. My name is Niels Stemser and I'm working for Shining 3D in EMEA as a regional sales manager. Today I want to just give you a short information about Shining 3D, afterwards about the AutoScan Inspec. And we have really a limited offer right now for the AutoScan Inspec and for the attendees of this webinar. So let's get started with the AutoScan Inspect and the Shining 3D company introduction. Shining 3D was founded in 2004 and is now focused on the 3D digitizing and 3D printing technology for around about 16 years. It's already a pretty long time. And over here you can see our main headquarters in China. If we look at the Shining 3D foundation and our technologies, we have basically two or three main foundations of the company. It's 3D scanning, 3D printing, and our internet cloud platform. As you can see, or maybe some of you don't know that we are also doing 3D printers, but we also have like FDM, SLS, SLM, and SLA printers. And that makes us also pretty unique because if you look at the global players on the market, most of them, they do 3D scanning or 3D printing. But we combine those two together to offer a whole solution. And the nice thing is that we know the process from 3D scanning to 3D printing and to get afterwards the result. The overseas organization is pretty easy explained. We have our EMEA headquarters in Stuttgart, Germany. Our headquarters itself, where we produce all the scanners, where we do most of our R&D, we have in Hangzhou, China. It's also the office for the whole APAC area. And last but not least, we have an office in San Francisco for the whole Americas office. I want to shortly introduce you the Shining 3D team structure. The team structure is pretty easy to explain, or I really like to show that because you can see our main focus over here. We have 48% of the whole company is in the R&D department, or they are technicians. So that's where we are focused on as well. As you probably know, we are introducing new softwares, new scanners, and we're updating our softwares most of the time for free. This is based on the 48% we have in the R&D departments, which is our main focus to develop new products, to make it more affordable for customers and to get a better user experience for our customers. Let's jump into our product and our product line. Basically, we have two different kind of products itself. We have the professional product line and the industrial product line. Professional is the Einscan, it's the Einscan SP, SE, and our Einscan 2X and 2X Plus. On the other side, we have our industrial, the metrology printers, at scanners and printers. So we have the AutoScan Inspec and Sparkle. We have the FreeScan X5, X7, and X3, and the Optim Scan and the FreeTrack. For all those industrial scanners, we will have this. We will have the session within this and last week. So I think last week you already saw the Optim Scan demonstration, and this week you will see as well the FreeScan and the FreeScan Track. The main difference between the professional and metrology scanners, there are the certifications. So for all the metrology scanners, you will get a certification for it for your quality control process. Let's look deeper into our AutoScan Inspec and Sparkle. Those are our two new products we have. The AutoScan Inspec is for, as it already says, for inspection, quality control, high accuracy reverse engineering. The AutoScan Sparkle, as you maybe already can see or imagine, it's for jewelry and to scan probably rings. Today I will just talk about the AutoScan Inspec. So let's check us out more details, all the small specifications we have over here. First of all, we can look at the process. So it's pretty easy to explain from the 3D scan to the STL, to any export into a 3D modeling software or inspection software. The applications are pretty easy to explain as well. It's a non-contact measurement, inspection and quality control, as I already said, reverse engineering, and for sure product design. I guess there are way more applications, but all our customers are using our technology in a different way. About the specifications of the scanner, you can always check our website, but we can just look over it pretty shortly. We're talking about like around about 10 micron accuracy. It has a 3x turntable. The camera resolution is 5 megapixels, so you can achieve a really high resolution and really nice details of the STL file afterwards. And for sure, the light source is a blue light. Pretty important as well. Keep in mind that the scanner only works with Windows. Hello, and welcome back to our webinar. As I said, today I'm going to introduce you our AutoScan Inspec. This scanner is our totally new unit, and I'm pretty excited to show you today all the functions of the scanner and explain in more detail what we can do with it. First of all, I'm going to explain a little bit more detailed what the scanner has and what comes with the scanner. So as you can see, the scanner over here, it's like how the scanner comes right out of the package. You will get blue tag with it, fixtures with it, so you can mount different parts on the turntable, on the 2-axis turntable over here. And for sure, you also get the software. I'm going to introduce you in some seconds. Let's start. As you can see over here, that's our software. It's the Inspec, or better called UltraScan software. We just gonna start a new project right now. We click on new projects, then this will pop up this screen. We just call our first object test number 10. And we can also save the scanning files in a save path. So I will use the default one, but you can also save it wherever you want to save the part and the STL file afterwards. Let's go on the single object mode first of all. We also have a multi-object mode, but this one I will explain you a little bit later in this webinar. Let's start. So we get our first view over here. And what I'm going to do right now is I'm going to fix my first part on the object. This one over here. So it's pretty easy. We have magnets here. We just stick it on and we will now start to scan it. As you can see over here, we have this cursor over here where we can adjust the brightness. Right now it's a little bit too bright, so I will just decrease the brightness a little bit. So I'm always saying red is bad. That's what we need to keep in mind if we think about the brightness adjustment of a 3D scanner. We also have a height adjustment. So as you can see, we have like a blue lane or a blue plane over here, and under this blue plane, everything will be deleted out automatically. So let's put us the plane over here, and what I'm going to do right now is I just press scan, and then the scanner will start automatically to scan the object, as you can see, and pretty fast as well, and from all the different angles we have over here. So just wait 1 second and the first scan process is finished. I think that looks already pretty good. We scanned almost everything, so I'm gonna move this cutting plane here. We don't need it right now. And I'm going back to my object, and I'm just going to turn the object around on the other side, because we want to scan the other side as well. Done over here. I'm going back to my object over here, back to my screen. I'm checking again if the height adjustment, everything is fine. Looks pretty good. And I now just press the button Flip Scan. So what the software will do right now, he will rescan the bottom part of the object, and afterwards the software will automatically align the two different scanning data together. Okay, it's almost finished. As you can see, I scanned a little bit of the blue tag over here. I could use my cutting plane to cut it out. I can also move the cutting plane a little bit. That looks pretty good. I think I'm kind of satisfied with the scan over here. There's one thing I can do right now is, as you can see over here, it's a really small hole over here, it's a really small gap. And I can like change the view here on my screen and just click on Add Scan. And what the software will do right now is the turntable will move to this position and scan it automatically, as you can see. So we can look deeper into holes over here and see the whole object itself. Okay, let's say I'm pretty satisfied with my scan. I can just try to capture a little bit more around here. I missed a little bit of this part over here. Just like try to scan it over here, perfect. That looks pretty good. So what I'm going to do right now is I'm just clicking alignment, and now the software will automatically, as I said before, align my first part and my second part over here. We're just going to wait. It takes a little bit because the software is searching for the perfect alignment way, and as you can see over here, it's done. We just press OK now. We have our file over here. Looks pretty decent, I would say. And if we are finished, we just click on Data Wrap. That means, actually just go back for a second. Currently, we're just working with the points, with the point clouds. And most of the softwares, it's really hard to work with point clouds. So we want to turn this point cloud into a triangles or an str file. So the next step is we go on Data Wrap. And we get the option to choose if we want to do a watertight or an unwatertight model. Watertight means the software will close automatically all the open holes I have. Unwatertight means the object will stay like it is, so the software does not manipulating anything of the data over here. We can also reduce the percentage. Let's say we want to reduce a little bit, 90%, because maybe the file will be too big afterwards, and we want to call the data name Test S. Unwatertight, as I said before, and we click OK. And now, as I said, the software is going from the points to an str file. We're just going to wait for a second until it's ready. Perfect. As you can see, our first scan with the AutoScan Inspec, and it took some seconds to scan it. If you are finished with the scanning data, because we will use this one afterwards to maybe do the inspection in Control X. So I'm just going to click on Complete. And now I just want to do the second scan. I have here like a golden part. And what I want to do for this golden part over here, I want to capture all the things, so I can do probably reverse engineering of this part. I'm just going to mount it pretty basically here on the blade. I have blue tack again, and due to the reason that this part is kind of golden and reflective, I'm going to use ASAP spray to spray the whole part and to get the reflectiveness away. That's where I can like increase the accuracy, and the scan result will look way better afterwards as well. The benefit of the spray is that it will disappear after 2 hours, so there's no cleaning anymore needed. I know for most of the scanning people, it's like a pretty big hassle to clean the part afterwards, or to spray next to your scanner, but with this spray, not a big deal anymore. So you don't need to be scared that you break your scanners, or you need to clean your part. So, we mounted the part on the scanner over here, and what we will do right now, we will just create a new project. Let's call it Gold 22. So like that over here. We will use the single object mode again, and we will click OK. What I didn't show you before, we also have the option to auto-adjust the brightness of the scanner. Currently we have a lot of black parts over here, or like a lot of black surroundings, so the scanner will not adjust perfectly the brightness. So we still need to do it manually, but if you have a bigger part, it works pretty good. Let's check the height adjustment. It looks pretty good as well. And then we can just move on and scan the object pretty fast. So after I finish my first scan, I will just flip my part and scan the other side. Okay. So now we've finished. Okay. I just want to show you like another option I have over here. And it is to scan, let's say, this part over here. I can just go on Add Scan, and the scanner will turn automatically in this position and just rescan this part, which I will need over here. Okay, this side a little bit. Perfect. And this side a little bit. Pretty good. If I have some noise, it's not a big deal. I can go on it again and delete it out without any problems. I didn't scan that much blue tag, just here a little bit. So I will activate my cutting plane right now. There we go again. I will click on apply. My cutting plane will be there. And let us cut this part over here, and we have like everything done. So I will just go on this blade over here, and then I will just flip my part. Okay, I will spray it from this side again. That's pretty good. Okay, so in the next step, just click Flip Scan, and the scanner afterwards will align those two scanning data automatically together. Okay, it's almost ready. There we go. Now we have it from this side, the cutting plane again, that we don't get something from the blue tag. We click on alignment, and the software will now automatically align both sides together. Due to the reason that it's a little bit a bigger file, it can take some seconds. In the meantime, we can just think about what is the benefit of this kind of scanner. And the benefit is that, first of all, as you can see, the software is pretty easy to use. So you don't need to teach your quality control people, you don't need to teach your engineers how to use the software, and 3D scanning is with this scanner really not a magic anymore. It's pretty easy to use, just set it up, calibrate it automatically, and start scanning. Another huge benefit is for sure that you can scan pretty small objects pretty fast. Due to the reason that with a lot of scanners you need to change the angle so much, for this scanner it's automatic because we have the 2x turntable. So you capture almost everything with one shot or with one go. We have the automatic alignment, as you can see over here, which makes it also pretty unique to use the scanner. We just press OK, we have the scanning data over here, and I will go on data. That means I will go again from the point cloud to the STL file. I will go for unmodded tile again because I don't want to have a closed model, and just press on go, and now the software will post-process the data. This can also take some seconds because it's like a really heavy process to post-process all the points we captured with this 5 megapixel camera. All those million points need to go to a triangle afterwards, as well as triangles. So almost finished over here. Just wait a second. In the meantime, we can already look at our last scanning object, and it's this part over here. It's screws, and it's a pretty unique function for our scanner that you can scan those screws with one go, all of them. So what we're gonna do is, I'm gonna spray that part again because I wanna get a better result, a really good surface. I check that I captured most of the parts. Okay. I remove the blade. I put on this plate. We can check out our scanning result over here. Looks pretty nice. So let's go back to the start. We go a new project. Let's call it Multi-1. And this time we will go on the multi-object mode over here. We press OK. We can check again the brightness. Let's make it a little bit brighter. As you can see on the blade, there are numbers. So those numbers are really important afterwards. We're gonna check the cutting plane, and then we go on start. Now the scanner does everything automatically again. We don't need to do anything. I can get a cup of coffee, or in Germany probably a beer. So let's get it over here. Pretty good. We have our scanning results over here. I have my cutting plane again. I don't need to cut it perfect right now, but let's do it this way. It's perfect already. And we go on data row. As you can see right now, we can still see the numbers over here. And now we can name our models. So let's say number 1 over here is product 1. Number 5 is product 3, for example, and number 3 is product number 2. I will do this time watertight because if I activate the cutting plane, my software will automatically close the scanning data perfectly based on this cutting plane. We press OK. It will take now a little bit more because we will do the watertight model. But you will see afterwards it looks pretty cool or pretty good with the cutting plane over here. Also the software will pop up now all the small parts. First of all number 1, then 2, then 3, then 4 until we reach the number 8. The good thing over here is that we can save, as you can see afterwards, all those small objects in like not in one STL file. Those will be like one each for each object. So I can like scan such things like pretty fast in one go, import it into my inspection software in Control X, very serve point shape, and do the automatic report afterwards. So we have a really huge time advantage for this function over here. So we are already at 70%. There are I think 2 missing. Or one is missing, and then no 2. Then we are good to go. So let's go. There we go, and there it is. Look at this result, beautiful. As I told you before, the cutting plane over here. That's the benefit if I will activate it and if I would do watertight. The good thing as well, if there would be any open holes still, I can fill hole manually by myself. I can like disable some objects if I don't want to see them, or I can even delete one of them. There we go. If I want to save them, they're already saved automatically in my folder, and I can just click on complete and do my next scan. That's basically it for the AutoScan Inspec. We will now move into the quality control process. So we scan one part, and my colleague David will show you now the quality control process, and how fast it is to do inspection together with the Control X software from Geomagic, from 3D Systems. So thank you very much for listening, and thank you very much for watching, and enjoy now the quality control process, and talk to you afterwards in the Q&A session. Bye!
So, hello, and thank you, Niels, for some nice short introduction for our new Inspect scan. So, now I want to show you some function of Control X. So, this is the UA from Design X. You have different function on the top. Under the home, you will see you can import, you have the alignment, compare, construction geometry, report. So in this case you have everything what you need to create a first report with 3D comparison and some other. If you need some more functions for measuring under dimensions, you will see that you have a lot of that. Also on the alignment there are some more alignments you can choose. But for the beginning, start with the home and say we can choose the import here or also the very top. So we click on import, we choose the step, import it, and now we have our step file. Or another way is you just go to the folder where you save it and just drag and drop your file you want to import. So now we have got our STL and CAD file in here. So as you can see, they are not aligned. So the first thing we are doing is national alignment. That's a very rough alignment but very helpful. I will show you later why. So start the national alignment, say OK. And now our two objects are roughly aligned. We can also say for this case, okay, best fit. We can choose if we want under use selector data only data from here some areas we are interested in for the best fit. So, but for now we will take all data and say OK. Alright, then we can do the 3D compare, and we can just click OK, or if we want to change some tolerances or something, click on next, and here we can change the tolerances, for example for 0.3, and now we have our first impression. Alright, so I can duplicate my result, which I'm doing now. I say duplicate. Alright, so Control X, if you have the step file and the STL file, it's quite helpful to get a very fast workflow, because the national alignment is so that the STL is now close to the step, and if I create a plane or something on my step file, it's automatically copied to my STL file. So when I switch it off, and also this 3D comparison, and I go on plane, and let me choose that plane for example, extract. I have also a lot of other methods I can choose, average, offset, endpoints, whatever. Now let's say we say extract, click OK, and here we see the green and yellow plane. That means that the plane is on the CAD file and as well on the STL. So if I just would do it on the STL, I click on plane, and I say extract, let's say from here, for example. I only have the orange plane. So this is why the initial alignment before helps you to align the two files together, and then you can just use the cut file to create your features and copy it automatically to the STL file. So we can delete that and also that. So now we have two result data, and we can change, for example, the alignment. So best fit we will delete, and we will choose 3 to 1, for example. Switch on our cut file that we can work better, and for first plane we choose, take the plane, we have vector, you can also choose plane or line or anything, plane, and position, circle. Alright, click OK. So now we have another alignment over here, and we see that there's an update function over here for our 3D comparison. So we will start that, and the software will start to calculating the new result based on our new alignment. So now it's done. Honestly, so at the moment I would say it looks really the same. So where is the difference? But we can go on Tools and click on Result Navigator, and here we have the result from data 1, and here we can put data 2 in, and now we see that there are some areas where the result is a bit different. Not much, but just a bit. So just to show you that the different alignment will give you different 3D comparison, and you can check in the result navigator how it looks and where the differences are. So we can go back on the model view, and I go on with database 1. So if I've done my 3D comparison, I can click on comparison point, and clicking on the area I want to see some more information. Just roughly here and in here. No results means STL data is missing or something. So okay, no worries. So if we only see the deviation. If we want to see more, we can click over here and say what we everything want to add in this file. So basic, something directly default, or simply, let's even say detailed, then you see a lot of that. So you can choose what you want to see and what is not good over here. Let's double check. We will switch off the 3D comparison and the reference, switch on the STL, and yes, as we can see here, there are no data, so that is why we are getting here no result. Alright, so we can also delete that. Alright. Okay, so next we can also do a 2D compare. So we are clicking on that, and we can choose base plane. We need our step file, then we can click for example, over here. We get the first plane, and then we can move that plane to a position where we need it. We can also make it smaller so that we only cut through this, or we want to cut through the whole file, and we can also turn it in that direction. And can also choose multiply cutting plane from a slot. So we have a lot of places. You can also say basic place from X or Y and Z. You can also choose directly and say we want to I want to go 1 second. Basic plane, click on here, then you are free again. Move it a bit. Say next, okay. And here you see now your results of the 2D comparison. We need to switch off the step and comparison. In here you see it now. So this is our 2D cut and the comparison to it. So what else in comparison of? So what is also important, of course, if we have our step file, we want to do some measurements. So under measurement, the measured is you can decimate, fill some holes, and such function. Under dimension, you can choose now 2D. You have geometric tolerances over here, and for example, you want to check the cylinder in there. You can choose smart dimension, and then you just click over here, and the software tries to figure out what you want. So in this case, we want the diameter. It's correct, and we can click, for example, on that plane and that plane, and then we get smart dimension says, okay, this is now angle you want to measure. Or I can also say, okay, I want my linear measurement from these two planes, as you can see here now. It's trying to get something. You can also reference back. What was that? That was this chart. So once again, on dimensional, click here, in material, or you can say in space. That's not what I need, what I want. Discharge, alright, no problem. So now we can also work with datum. You can create on your STL file. So we have, let's say, datum A over here. Say apply, and I want to check now if this plane is parallel to the top one. Nope. So that plane to datum A. I can change my tolerance here, say just okay. So it's 0.1 I adjust. Actually it is more, so it fails. But this is, you can work GD&T functions, and also what you can do if you click now, let me switch it off. Alright, so okay, if you click on 2D, you need to add a section, and for example you can click on that plane, then you can move that plane to the cutting area you need and say OK. And here you can see that the black lines is the cut file, and that line is from our STL. And also here I can now use the smart dimension. Just click, and here I have my radius, say OK, or angle from here to here, OK, and then I can say exit, and now I have so far everything I want for my report, let's say. Then I click on home and I can click on generate reports. One thing that's quite nice and also good to check before, if you look over here and click on the function, you will see in the little down window down here the preview of the result in the report. So if I would do it now like that, I will see in the report that view. So this is not what I really want. I want to have, in this case, let's say this view with a better understanding, and then I can change its viewpoint. I can zoom a bit more in, down here, or close here. Okay, change it. You put down, and then you can find the perfect position. 2D comparison, that is fine. This one, switch it off. We can say alright. So if I can't find it because I have 3 over here and I move it, and disappear at that point. So I can say that this one and the radian will say the other one I will now select and move to group 1. I have to select it. Group, add group. Here we have group 2, and I select these 2 again, and I to move to. So then I can say, okay, for my group 1, I want to see my variations. I click on next, and now I have it. And so I can also go on group 2 now. And say like that. Okay, update. And so I can do with all my functions. And then if I checked everything and everything is good, I can click on generate report. I can fill in product name, missing. Part name, test, part number 1, department shining 3D, inspector, DW. And here you can choose what you want to have in your report. So if you something you don't need, for example, the nation alignment I'm not interested in, I just want to see the best fit alignment. You can kick it out, click on generate. here first you see the cut file, your STL file, the best fit alignment with the information, 3D comparison, and then what we add from 2D comparison, our cross section, our group for group 1, group 2, and so on. Or if you want to have your company logo in, that's not a problem. You just choose the 3D Systems logo, say, and then you can click on import and put anything in what you like, or just let it out. Then you can click on PDF, PowerPoint, or Excel to save it. Say test messing. And now I have my report as a PDF. One last point I want to show you very quickly. I will delete the second result. I will copy that, duplicate, and over here I can choose now replace measure data. I will click on it. I will click messing 2, import only, and then do you want to reply them to, and say yes. So, and now as you can see, the new one is not aligned, it's very random, but if I click on update button, everything will start automatically from the beginning as you have done before, and all the steps will be done now automatically. So quite a nice function if you have a lot of the same STLs file and want to compare them easily in the automatic. That is how you could do it. And now we have the same stuff for our second object. Alright, so far that gives you a short overview from Geomagic Control X. Please stay in line, we will answer some questions after that, and will nice to speak to you. So thank you for watching and see you. Bye.